now we're going to look at using strategies like factoring and some other strategies to talk about how we can solve quadratic equations. And in this video, we're going to look at two. We're going to look at using factoring as a method, and we're going to look at using the square root property as a method to solve quadratic equations. So a quadratic equation, remember, equation means that there is an equal sign. An equation can be solved. Everything we've worked with up to this point with our quadratics and with factoring, we've been factoring expressions. So there was no solving because it wasn't equal to anything. But now a quadratic equation can be written in the general form, ax squared plus bx plus c equals 0. That is general form. And the reason why we want to set it equal to 0 is because what we can do is we can factor it and we can apply this zero product property. And so the zero product property says if I have two things, A and B, and I multiply them and the result is 0, the only way that that can happen is if A is equal to 0 or B is equal to 0. That's the only way that you can multiply and get a product of 0. They could both be 0. We don't know. But one of them has to be 0. So if we want to use this idea to solve quadratic equations by factoring, then our first step is to get the equation equal to 0, and then we can factor and apply that zero product principle. So if I look at number 11, let me make my pen big again. We want to factor this. It's already equal to 0, so that's good. Let's see if we can factor it. And I can because there's a GCF. So if I factor out 2x, I get 2x minus 1 equals 0. Now what that zero product property says is that either 2x has to be equal to 0 or 2x minus 1 has to be equal to 0. And you can probably solve those equations in your head, and that's fine. And so we get two possible solutions, either x equals 0 or x equals positive 1/2. And again, Math Lab may want you to use a set. They'll usually preload it, but so we can put our solutions in a set like that, okay? On number 12, this is not set equal to 0, so it's not set up to be able to use that zero product property. That's why it must be equal to 0. So we'll start by subtracting 4, okay? And now we want to see if we can get this factored. Now, again, I don't care what method you use to factor as long as you can get it factored. We need our outside and our inside to add up to 7. So if I put 1 and 4, I get 8 and 1. And since I want negative 4, that means that I can make this one negative and this one positive. And if we do a quick FOIL in our head, we get 2x squared plus 8x minus 1x, so that gets a 7x, and then minus 4. So I factored it correctly. And so again, now we look at each one. This first factor, if 2x minus 1 is equal to 0, add 1, divide by 2, we get x equals 1/2. And if x plus 4 is equal to 0, subtract 4, we get x equals negative 4. And so negative 4 and 1/2 is our solution set. So I'd like you to pause the video, try 13 and 14 on your own, and come back here in 3 seconds for your answers. All right, here are your answers. Double check with your work. And if you find that you're struggling with this, then you can send me an email and we can talk through that tonight while you're working if you need to. So that's the idea of solving by factoring that we've done before. Let's now look at square roots, which is the second option that we're working on today. For the square root property, if we can set up our equation so that we have something squared equal to a number. Now that u could be anything. It could be x, it could be x plus 7. It might be an expression rather than just a variable. And d is going to be some positive number. It has to be positive. Remember, we can't square root a negative. That's how we get imaginary solutions, which we're not working with yet. The rule is always that when you take the square root of both sides, you get either the positive or the negative root. Remember that that happens when we introduce the square root. Not just because there's a square root there, but when we use square root as a tool, that's when we get plus or minus. So if we look at number 15, for example, We don't want it to be equal to 0. Instead, if we're going to use a square root, what we want to be able to do is get the x squared by itself. So I'm going to start by adding 15 to both sides, and then I'm going to divide by 3. So I get x squared equals 5. Now I'm ready to take the square root of both sides, and when we do that, the answer is going to be plus or minus the square root of 5. Leave your answer as a radical. Do not convert to a decimal unless they tell you to, because square root of 5 is an exact value. 2 point whatever is an approximation, and that's not what we want. Now, in my math lab, they're typically going to ask for a solution set, so you won't use plus or minus like that. You'll write it out as negative square root of 5 and positive square root of 5 as your two solutions. I believe that's what they want in my math lab. Number 16 is an example where that u part is an expression. It's x minus 2. It's not just x by itself. But as long as we get the squared piece by itself, then we can use the square root. So I'm going to start by dividing by 3 on both sides. That way I get my squared expression by itself. Now, to get rid of that squared, I'm going to take the square root. So what we get now is x minus 2 equals plus or minus the square root of 6. And now we're still not done because we actually haven't solved for x here. So we're going to add 2 to both sides, and we always put the radical at the end. That's kind of the standard form way that you would write it. So I'm actually going to put the 2 in front, so it says 2 plus or minus the square root of 6. And then again, in my math lab, we would need to say 2 minus the square root of 6 and 2 plus the square root of 6. Those are our two separate solutions written out using set notation, okay? And so that's where we're going to stop for today, is just those two methods. We'll come back and do quadratic formula and completing the square in the next video.